Welcome to Key. Today, we are going to get right into the heart of our digital world, and we're going to uncover the single most fundamental piece of math a computer can possibly do.
It's a great question, isn't it? I mean, how does a device that thinks only in zeros and ones manage to calculate, well, everything, from your bank balance all the way to a rocket's trajectory? You'd be surprised. The answer starts with something incredibly simple. You see, before a computer can dream of tackling complex calculus, it has to master the absolute basics. We're talking adding 1 plus 1. Yep, every single massive calculation you can think of is built on this one tiny operation. So let's see how it's done.
And this is the little circuit that does it all, the half adder. Seriously, it's the most basic digital calculator you can possibly imagine. Its entire job is just to take two single bits, two ones or zeros, and add them up. That's it. This is the very first step in all of digital math.
So, why the name? The adder part is pretty obvious. Of course, it performs addition. But why half? Well, it's called a half adder because while it can generate a carry to be used in the next step, it can't accept a carry from a previous one. It's kind of like it's only doing half the job of a full-blown adder.
So, how does this tiny circuit actually do its thing? Let's pop the hood and take a look at the logic gates that really make it all happen.
In its most simple form, a half adder only uses two logic gates. You have two inputs, let's call them A and B, and they get fed into both gates at the same time. An XOR gate, that's exclusive OR, calculates the sum, and at the very same time, an AND gate is calculating the carry. Two simple gates giving us two very important outputs.
And this table here, the truth table, shows us exactly how it all works. It's the blueprint for the circuit. So, if both inputs are 0, the sum is 0, and the carry is 0. Easy. If one input is 1 and the other is 0, the sum is 1 and the carry is 0. Still with me? But now, look at that last row. When both inputs are 1, the sum is 0 and the carry is 1. And in binary, a 1 followed by a 0 is the number 2. 1 plus 1 equals 2. The circuit works perfectly.
The most important thing to get here is that this table isn't just a guide, it's a guarantee. It shows every single possibility and proves that our simple two-gate circuit will get the math right every single time. This is the real foundation of digital reliability.
But what if you don't happen to have an XOR and an AND gate lying around? Well, the beautiful thing about digital electronics is there's usually more than one way to get something done. Let's see how we can build this with different parts.
Believe it or not, you can build a totally functional half adder using only NAND gates. The NAND gate is what we call a universal gate because you can combine them to create any other kind of logic function. It's like having just one type of Lego brick that can build literally anything you can dream of. And you know what? The NOR gate is universal too, just like the NAND gate. So you can get the exact same result adding 2 bits just by wiring up a circuit using only NOR gates. This kind of flexibility is absolutely crucial for efficient digital design. And here's a fun little fact for you. It takes a minimum of 5 of these universal gates, so either 5 NAND gates or 5 NOR gates to create just one half adder. Just 5 tiny switches all working together to do the very first bit of digital math.
Okay, so we've got this simple little circuit that adds 2 tiny bits. Why on earth does this one little component matter so much? Well, its job is way bigger than you might think.
This humble circuit is an absolute workhorse. It's a key part of the brain of your computer, the arithmetic logic unit, or ALU. It's what makes every digital calculator work, it helps your processor find data in memory, and it even helps organize data tables. It's literally everywhere.
Just think about it for a second. By combining a whole bunch of these half adders together with some other logic, we can build circuits that add 8 bits, 16 bits, even 64 bits all at once. Every complex calculation your computer does starts with the simple logic we just went through.
So, if there's one thing you take away from this, let it be this. The half adder isn't just a simple circuit. It is the fundamental building block of all digital arithmetic. The entire world of computing is built right on top of this beautiful, simple idea. Which, of course, leaves us with a pretty interesting question to think about. We've seen how to add 2 little bits, but that's just the start. What does it take to handle that carryover bit and build a circuit that can do continuous, complex addition just like a real calculator?
If you found this explanation helpful, please do like and share it. And of course, be sure to subscribe to Key for more deep dives into the tech that shapes our world. Thanks so much for watching.